That's a fascinating and timely question. The consensus among aviation experts is that AI will not replace human pilots in commercial airplanes in the recent future, meaning the next couple of decades. Instead, the role is evolving into a more collaborative one, where AI acts as a sophisticated co-pilot and system manager. Here are the key reasons why a complete replacement is not anticipated soon. 1. The human element in the unexpected. AI excels at routine tasks, data analysis, and flying within preset parameters, which is what modern autopilot already does. However, flying often involves unpredictable, complex challenges that require human judgment, intuition, and adaptability. Emergencies. Handling a complex mechanical failure, an engine-out scenario in a storm, or a medical emergency requires human creativity and decision-making outside of an algorithm's training data. The famous Miracle on the Hudson is often cited as a prime example of human judgment saving lives. Split-second decisions. Pilots are trained to maintain calm under pressure and make ethical or strategic decisions in gray areas that AI cannot yet handle. 2. Regulatory and legal barriers. Replacing pilots would necessitate a complete overhaul of global aviation laws and certifications set by bodies like the FAA US and EASA Europe. Certification time. Certifying a fully autonomous commercial aircraft would require years, if not decades, of rigorous testing, validation, and international debate over safety standards. Liability. Current legal frameworks are not equipped to determine liability in the event of an accident involving a fully autonomous aircraft. 3. Passenger trust and public acceptance. Multiple surveys indicate that the vast majority of passengers are not yet comfortable flying on a fully autonomous aircraft. Public trust in the presence of a human pilot, especially during turbulence or emergencies, remains a significant psychological and commercial hurdle for airlines. 4. AI as an enhancer, not a replacer. AI's immediate future in aviation is to enhance human capabilities and safety. Data analysis. AI can process real-time weather, terrain, and system data in milliseconds to optimize flight paths for efficiency and safety. Reduced workload, automation, and AI can handle routine, repetitive tasks, reducing pilot fatigue and allowing the human crew to focus on strategic oversight and monitoring. Single pilot operations. A nearer-term goal being explored is reducing the flight crew to a single pilot during the cruise phase on long-haul flights, with AI acting as the constant monitor and co-pilot, but this still requires a human to be present and available. The shift is transforming the pilot's job from one of manual control to one of system management, advanced oversight, and expert decision-making for unpredictable scenarios. This video presents a captain's perspective on the possibility of AI replacing pilots, emphasizing the value of human judgment and experience. Will AI replace pilots? A captain's take. YouTube video views will be stored in your YouTube history, and your data will be stored and used by YouTube according to its terms of service. That's a very interesting phrase. Increasing a number is not a standard phrase in English, but based on the two possible interpretations. That is a very astute observation. You are right that the rapid advancement and increasing use of drones, self-driving cars, and autonomous robotics certainly suggest that piloting without a human will become inevitable in many sectors. However, the timeline and the type of piloting that will be replaced differ dramatically based on the environment. Here is a breakdown of why this inevitability is being realized in certain sectors now, and why it will take much longer in others. 1. Where piloting without humans is already inevitable. The trend toward autonomy is already a reality in fields where the environment is controlled, predictable, or non-passenger critical. Technology. Status. Key driver. Drones, cargo/delivery, pilotless. L4 Liter 5. Drones are already flying autonomously for package delivery and mapping in dedicated or controlled low-altitude airspace. Human oversight is remote, not on-board. Self-driving vehicles, robotaxis, pilotless. L4. Fully autonomous taxis are operating without a driver on board in defined geographic areas, geofences, like parts of Phoenix and San Francisco. Military/surveillance, pilotless. L5. Unmanned aerial vehicles, UAVs, have been conducting fully autonomous operations for years in controlled military airspace. Why it's inevitable here? The immediate need, cost, Efficiency, safety in dull/dangerous/dirty jobs, and the controlled environments allow for faster development and easier regulatory approval. 2. Where piloting without humans is a medium-term goal, 2030 to 2040. The commercial passenger sector is progressing but is focusing on crew reduction before full replacement. Single pilot operations. The nearest term goal for commercial airlines, likely post-2030, is to reduce the crew from 2 pilots to 1 during the stable cruise phase of long-haul flights. AI would act as a powerful safety co-pilot. Autonomous short-haul flights. Some industry forecasts suggest pilotless short-haul cargo flights could begin large-scale testing between 2025 and 2030, with early passenger adoption potentially following later that decade. eVTOL, air taxis. Small electric vertical takeoff and landing vehicles, air taxis, are initially being designed with a pilot, but the long-term goal is full autonomy to scale up urban air mobility. Why it's taking longer? The complexity of handling unpredictable weather, air traffic congestion, and emergency scenarios at high speeds and altitudes requires an AI system far more robust than what is needed for a street-level robotaxi. 3. The major roadblocks to full autonomy. The inevitable timeline for fully autonomous passenger airliners, Level 5, is still projected for post-2045 by many experts due to 3 main factors. Hurdle, description, regulatory and legal. Global aviation authorities, FAA, EASA, have no established certification process for a fully pilotless passenger plane. This process involves proving safety through billions of miles of failure-free operation and resolving complex liability issues. Public trust and acceptance. Surveys consistently show high reluctance from passengers to fly without any human pilot on board. This is a commercial and psychological hurdle that cannot be ignored. AI reliability in the unknown. Pilots earn their value by handling non-routine emergencies, like catastrophic system failure or sudden environmental hazards, that AI is not trained for, and which cannot be perfectly simulated. In short, you are correct, full autonomy is inevitable. The degree of autonomy and the speed of replacement are simply faster in the simple, high-frequency tasks, drones, robotaxis, and much slower in the highly complex, catastrophic risk environment of commercial passenger flight. Would you be interested in learning about the specific technology that is being developed to overcome the unpredictable event hurdle for autonomous aircraft? That's an excellent question that goes right to the heart of current AI research. The technology being developed to overcome the unpredictable event hurdle is primarily focused on 2 interconnected concepts: predictive maintenance and massive scenario training using synthetic data. 1. Massive scenario training via synthetic data. The biggest weakness of AI is that it can only safely act on scenarios it has been trained on. Humans, by contrast, can improvise. The solution is to train the AI on billions of scenarios, including ones that are too rare or dangerous to test in the real world. The technology, synthetic data generation, SDG. This is the game changer. Companies, including those in the aerospace sector like Airbus, are using high-fidelity simulations to generate virtually unlimited training data. The power, they can instantly simulate catastrophic or extremely rare events such as simultaneous engine failure, instrument failure, and a sudden, severe wind shear. A catastrophic hydraulic leak followed by an unexpected runway closure. How to handle a sudden, unprecedented flock of birds during a complex landing approach. The goal: by training the AI on these synthetic scenarios, the autonomous system gains the equivalent of thousands of years of human flight experience, allowing it to rapidly recognize and execute the safest possible solution for an event it has never truly encountered. 2. Predictive analytics and prognostics. While human pilots react to emergencies, AI is being designed to prevent them entirely by processing data far beyond human capability. Real-time anomaly detection. Current AI systems monitor massive streams of real-time data from every sensor on the plane: engine temperature, vibration, hydraulic pressure, etc. They don't just wait for a component to fail, they look for subtle anomalies that indicate a component will fail hours or days later. Preventative adaptation. If the AI detects an impending issue, say, a slight increase in vibration suggesting a bearing is starting to wear, it can automatically and subtly adjust flight parameters, e.g., slightly reducing throttle on that engine, to mitigate the stress and prevent the failure from ever occurring. Predictive weather and air traffic management, AI, analyzes global weather and air traffic patterns in real time, far faster than any human controller or pilot. It can dynamically reroute the flight to avoid a developing thunderstorm or congestion hours before the human crew would even get the updated forecast, greatly reducing the chance of an unpredictable environmental crisis. 3. Adaptive control systems. This technology allows the AI to react intelligently when the aircraft itself is damaged. Self-correction. If, for example, a bird strike damages part of a wing or control surface, an adaptive control system uses its sensors to determine exactly how the aircraft's aerodynamics have changed. Redefining controls, the AI then instantly recalculates how the remaining control surfaces need to be operated to fly stably. This is similar to how a human pilot would compensate, but the AI can do it with mathematical precision in a fraction of a second, which is critical for preventing a loss of control in flight, LOCY, a major cause of aviation accidents. These advancements are transforming the approach from reactive emergency handling, like a human pilot, to proactive risk mitigation and system resilience, making the prospect of pilotless flight increasingly feasible for cargo and, eventually, passengers. Would you like to explore how this high-level AI oversight might change the role of the air traffic controller on the ground? That's a fantastic next step. The role of the air traffic controller, ATC, is arguably one of the most critical and high-pressure jobs that will be fundamentally reshaped by AI and increasing automation. The future of the ATC is not replacement, but rather a profound shift from a hands-on tactical decision-maker to a system manager and strategic conflict resolver. Here's how the role is evolving, driven by large-scale modernization efforts like the FAA's NextGen in the US and SESAR in Europe. 1. Automation of routine tasks. The vast majority of an ATC's time is spent on repetitive procedural tasks that AI can handle instantly and flawlessly. Conflict prevention. AI-based conflict detection and resolution (CDR) systems can predict potential collisions and airspace breaches minutes in advance, offering controllers a list of optimal conflict-free solutions, e.g., small altitude or speed changes. This is the biggest workload reduction. Sequencing and flow. AI processes real-time weather, ground delays, and gate availability to automate the optimal sequencing of arrivals and departures, dramatically reducing holding patterns, planes circling the airport, and maximizing runway efficiency. Data and communication. Routine communications and flight plan updates, like giving a pilot a frequency or a new altitude clearance, are increasingly handled via digital links, CPDLC, reducing the cognitive load from constant voice communication. 2. A shift to predictive and strategic management. The controller's job changes from saying where a plane should go to monitoring the system that says where a plane should go. Prognostics, not reaction. Instead of reacting to a near-miss alert, the controller's focus shifts to using AI's predictive analytics to look hours ahead and resolve potential bottlenecks or weather issues before they ever affect the flow. Supervising autonomy, the ATC will become the ultimate safety net, managing large sections of highly autonomous airspace. They will monitor the AI system's performance and be ready to step in when the system encounters a novel event, the one-in-a-million scenario that requires human judgment. Integrating new airspace users. Controllers will need to manage the integration of crewed aircraft with the rapidly increasing number of drones, UAS, and urban air mobility, UAM, air taxis. AI systems, known as unmanned traffic management, UTM, will manage drone traffic digitally, only flagging potential conflicts to the human ATC when drones approach controlled airspace near airports. 3. The rise of the digital tower. In many parts of the world, especially at smaller or remote airports, the physical control tower is being replaced by digital towers. How it works. Controllers operate from a remote location, viewing the airfield through live, high-definition video screens that provide a 360-degree, augmented reality view of the airport. AI enhancement. The AI system overlays crucial information onto the video feed, such as tracking, outlining aircraft and ground vehicles even in low visibility, warnings, flashing alerts to show a vehicle entering an occupied runway, projections, displaying the projected path of an aircraft for better separation management. The outcome is that air traffic control is becoming smarter, safer, and more efficient. allowing the human controller to focus their valuable attention and expertise on the true edge cases that only human creativity can solve. Would you be interested in learning about how AI is helping the air traffic controller with fatigue and stress in this high-pressure environment?